so much work, I know. Law number 6 is your final law in chapter 3.2, and it is exponents of 0. I'm going to call it exponents of 1. No, we're not. I'm going to call it exponents of 0. Exponents of 0. Now, before I go on any further, Riley, I want you to take a guess. What will this be worth in standard form? You think 0. How many agree with Riley that's probably going to be 0? Might be 2. I agree with that. Guess 2. Let's have a vote. How many think it's 0? Nobody. How many think it's 2? Nobody. How many are so disinterested in what the answer is they're not raising their hand for either one? The answer is 1. Law number 6 will say all powers with a 0 exponent will have all powers with a 0 exponent, all powers with a 0 will have a standard form of 1. That's the law. All powers with 0 exponent will have a standard form of 1. I'll explain why. Here's what I mean. So I'm going to give you an example, and the first example I'm going to give you is a simple one. 4 divided by 4. Bree, you remember this in grade 6 probably, and you were told any number divided by itself. If I have $4 divided between 4 friends, 4 bananas divided between 4 monkeys, each friend will receive how many bananas, how much money? 1, correct? So we learned at a very early age that any number divided by itself is 1. That's a basic fact in the world of numbers. If I think of it in the world of powers, I know that this question could be written as 2 squared divided by 2 squared. That's the red question and the black question, Tiana, since you're locked in and copying this down, are the exact, well, I just wrote it and you didn't write it down, are the exact same thing. So the black question, 4 divided by 4, and the red question, 2 squared divided by 2 squared, are the same thing. And we know from Law 2 that when you have a power with the same base, you can keep the power and subtract your exponents. So from a power standpoint, when I solve this using Law 2, I see the standard form becomes 2 to the exponent of 0. And therefore, that is your proof that 2 to the exponent of 0 and the number 1 have the same value, right? And we could also look at it a different way. We could also look at it from table form. If I was to go 2 cubed, 2 squared, 2 to the 1, and 2 to the 0. Oh, sorry. Actually, I'll go to 2 to the 4. I'll push it out one more. Hang on a second. Let's go. If I was to give you this question here, I said, okay, evaluate each standard form. I would say 2 to the power of 4 is 2, 4, 8, 16. 2 to the power of 3 is 8. 2 to the power of 4 is 4. And if I pause for a second, what do I see about my standard forms as I decrease in these powers of 2? What's really happening to them as they go down? They're being cut. They're either being cut in half. We can think of them as being cut in half, or they're being divided by 2, or they're losing a factor of 2. They're losing a multiplication of 2 each time they go down. So they're being divided by 2, or they're being 1 less times 2 taken away. So then we know that 2 to the 1, we also now know that any power to an exponent of 1 is itself. It doesn't change. And if I cut that in half one more time, I get 1. So either way you think about it, this is the proof. You could say that if I take any power and divide it by itself, I get 0. If I change these exponential forms to standard form, I will be dividing a number by itself, in which case they will be even. Now, if I just go, I'll take a blue ink here. I'll do one more. So let's just take one we also know. Let's take 3 cubed divided by 3 cubed. Okay. So if I use the law, keep my base, subtract my exponents, I get 3 to the power of 0. Riley, do you agree? Okay. If I don't use my law, if I just simplify with BEDMAS, 3 cubed is what number? 27. We've now done it a few times. And then 3 cubed is 27. Any number divided by itself is 1. So we've now proven that 3 to the exponent of 0 would also have a standard form of 1. And you could do that infinitely with infinite different examples. Correct. 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 Look, let's take a negative base. Remember, negative 4 is the base because it's in brackets. If I take negative 4 squared divided by negative 4 squared, the law says keep the base, subtract your exponents. Your answer will be negative 4 in brackets to the power of 0, exponentially. If I think of it in standard form, what is negative 4 squared? It is 16. So I'd have 16 divided by 16, which equals 1. Proof. I'll do one more just because I want to make it a negative standard form. I'll put it up here. There you go. One more, I'll do it in black ink. Let's go negative 2 cubed divided by negative 2 cubed. We know keep the base, subtract your exponents. My answer would be negative 2 to the 0 in exponential form. If I think of it in standard form, what's negative 2 cubed? Riley, you did so good with 2 cubed. What's negative 2 cubed? Negative 8 is correct. So I'd have a standard form of negative 8. You can put it in brackets. You don't have to have it in brackets anymore. It's not necessary, but we'll keep it in brackets. What's 8 divided by 8? 1. What's a negative divided by a negative? We know from our sign laws it's still going to be a positive 1. A negative divided by a negative is still a positive 1. So no matter which example you look at, the red, the green, the blue, the black, they all end up saying that any power to an exponent of 0 will have a standard form of 1.